All right. Good morning, everybody. How are you doing? Thanks for coming out. This talk today is about threat intelligence automation and specifically about using a software product called Jupyter Notebook. And first of all, I want to, let's see, go next slide. All right, sorry. So I'm the Director of Research Innovation at Threat Connect. My team does research at Threat Connect into emerging threats, stuff that is pertaining to our customers and stuff that is interesting for us as well. And so some of the methodologies that we use for our team, what I like to do and what our team has done over the years is when we develop methodologies and have ideas about how to collect and analyze and disseminate threat information and threat intelligence. We also like to share our techniques and share the ways that we do it. And I'll go into the specifics of why we do that so that, the obvious is making sure that other teams out there are able to do the same thing at the same level that we are. So today, specifically, we'll be talking about Jupyter Notebook. But before we get into that, I want to talk about specifically what is threat intelligence. So if you're not familiar with this, if you don't come from an intelligence background, or if you come from, if you're not in the threat intelligence or CTI, cyber threat intelligence community or anything like that, there's some definitions and some ideas that I want to get out of the way at the beginning of the talk. So there are a few types of threat intelligence that we are not going to be talking about today, but I'm going to define them just so that you know the different realms of what we're talking about. So tactical intelligence, this is attacker methodologies. So understanding attacker methodologies, understanding their tactics, techniques, and procedures. As far as threat intelligence in the information security world, the word TTP I don't like as much as the sort of more descriptive and using English words term of attack patterns. So the different attack patterns that an adversary uses to attack its target or its victim, these are understanding these attack patterns. This is tactical intelligence. But we're not going to actually talk about that today. Operational intelligence, this is details of a specific incoming attack. So if you have, if you're monitoring social media or you're monitoring chat logs or you're monitoring stuff and you can see an attack coming. So if you've been able to, go through the intelligence process and then you come up with, an incoming attack of some type, this would be operational intelligence, knowing what type of attacks are coming at you at a particular time, and also the ability to determine, what your ability to repel and determine future attacks. So we're not going to talk about that one as well. Strategic intelligence, this is sort of a very, very high level type of intelligence. So this is, it involves, the decision makers at an organization, and it involves, understanding the risk involved in the different activities and systems that you have, in your organization. So doing critical assessments of risk and then communicating that to decision makers so that they can take this strategic intelligence and make decisions based on that. But today we're going to be talking about technical intelligence. So technical intelligence is specifically indicators of compromise, indicators of specific malware, malware families, and determining relationships between malware families, and also just understanding the details of malware, which in the diamond model of intrusion analysis, these are understood as capabilities. And we'll also be talking about the idea of infrastructure. And so capabilities are things like a phishing email or a malware implant that are put on your network. And then infrastructure are all of the IP addresses and servers, URLs, the transmission system that takes the information from the capabilities, the malware, and that sort of thing, and then transmits that exfiltrated data or command and control back to the adversary. So we're going to be talking about that today. And the intelligence process, just to kind of continue on some of the education part of this. So the intelligence process is a circular process. So it works in a circle, and you have your planning and direction stage, and then collection. So we're not necessarily going to be dwelling in the collection stage today, but the processing and exploitation. So this is sort of the first thing you do is you have someone using software like Jupyter Notebook, and then they're mined and going through the stuff that has been collected and turning it from raw data into information. So it's not necessarily the point where you're turning it into analysis. That's the next part. So analysis and production is, instead of, you don't have analysts looking at raw data. You have analysts looking at information. So the analyst looks at the information and then analyzes it, produces, an intelligence product, and then disseminates that out to the, to the customer or the client or whatever. So in a different way, I'll show you kind of where what I'm going to talk about sits in this process. So this is the area that you're collecting the data from. So in our case here, it's open source intelligence. So you're just collecting malware from wherever on the internet that you can. So you're pulling in malware files and analyzing them. And so you have all of this data, all this stuff out in the operational environment, and then you're collecting it from that environment. And then after you've collected it, you have a pile of data. So then what do you do with this pile of data? So this is exactly what we're going to be talking about today. So processing and exploitation, where you take a pile of data and then use a tool like Jupyter Notebook, and you turn that into information that an analyst, a malware analyst or a threat analyst can then look at and make decisions as to what is actually happening. And then you have intelligence at the end of that. So I also want to talk about where, why I want to share techniques like this and why I want to share processes like this. So David Bianco has what's known as the pyramid of pain. And so this is from the adversary's perspective. So from the individual or the group that is attacking your network or attacking your organization, what are the things that you can do? What are the things that you can take away from that adversary, and how painful is it for that adversary to replace it with another of the same thing? And so it's really trivial if you find hash values of the capabilities of the malware that they're using against you. So it's quite easy for someone and specifically if you are an adversary and you have compiled a particular piece of malware, it's very easy if you've already deployed that malware to change it a little bit, recompile it, and then you've taken away the hash values. So the malware itself is slightly different, and so that sort of really basic data point of hash values is trivial for them to regenerate. IP addresses. So this is an IP address of a server that you have either compromised, or if you're running your own, dedicated server that you've bought to run your malware operation. Those are also they're not as easy to regenerate as this, because it involves like you have to go out and compromise another IP address or compromise another server, or you have to go and buy buy time on a virtual private server or something like that. So IP addresses are slightly easier to regenerate after you've discovered the adversary's IP addresses and you've kind of taken that away. And then domain names, again, domain names, if you compromise someone's domain, or if you have begun registering your own malicious domains, there's either money that you need to steal from somewhere and then pay for these domains, or you have to spend time compromising other people's domains. And so this is slightly more difficult if you take that away from the adversary. And then as we go up, so network and host artifacts, these are not necessarily hash values, but these are more complex kind of behavioral patterns and artifacts that malware leaves behind when it works inside of a computer. And so changing the way that your malware behaves inside of a computer is much more difficult for the adversary than just recompiling it and changing some of the data that's in a section or something like that. And then tools. Once if you are an adversary or adversary group and you've had a team of developers writing a whole malware ecosystem for you, and that is your tools, your tool chain. If that gets blown and someone, if it's known that this is you, or if that particular tool stops working, or there's some way to block it, then you have to start over with that entire tool chain, and you have to have developer time, like working on developing a new, different, type of malware. And then TTPs. So this gets more into the kind of the mind of the attacker, where they tend to do the same type of process when they attack you. Certain adversaries will have that same kind of characteristic process that they go through, which can include their reconnaissance phase, that can include any part of the attack. And so this is the part, this is the part that I want to tackle the most whenever we want to help other organizations and kind of share our processes. What I'm trying to do is have a mirror of the pyramid of pain, where this is the stuff that is annoying for the adversary, or bad for the adversary, and then sharing something that mirrors this is sharing something that helps you determine TTPs is kind of more difficult for the defender. And so these are the things you want to aim for, sharing the different things that you use to combat these different pieces of the pyramid of pain. And so what I want to, the ultimate goal is to share processes and tools that let the defender, kind of attack the adversary's TTPs. So all of that aside, let's get into the really cool stuff. So Jupyter Notebook. Who here has heard of Jupyter Notebook? 2 people. All right. Let me rephrase the question slightly. Who here has heard of IPython Notebook? 1 nodding head. All right. So they're actually the same thing. IPython Notebook is the older, less pretty, not JavaScriptized, not web version of Jupyter. So the IPython project became Jupyter, and they rebranded and renamed themselves. So what this is notebook programming. And notebook programming is based on cells, and in sort of the way you think about this, as far as the types of development processes and the tools that you use. So I think everyone has heard of a REPL, even if you haven't heard of that term being used for it. So read, eval, print loop. What this is, when you log into a command line, and then you type Perl, P-E-R-L, or you type Python, the thing that appears lets you type in line by line code. So the technical, like the medical term for that organism, that is a read, eval, print loop, so an REPL. So a monolithic script, obviously this is where you open it in a text editor or some sort of IDE, and you edit a monolithic script, and then when you're done editing it, you run it, and then you see what its output is, and then you change pieces of it, and then you run it, and you see what its output is. So that's a monolithic script. So notebook programming is some sort of hybrid where you get some of the benefits of being able to run a line of code and then see what that line of code's output is, and then you also have this sort of you have the benefits of looking at your monolithic script at the same time. So we're going to see exactly what this looks like in a moment. So before I go into some of the Jupyter Notebook stuff, I want to share with you some kind of little cool details of stuff that I've just come up with on my own to figure out like how to make notebook programming safer a little bit, because you're going to be working with API keys and credentials. And so, as we all know, it is a very, very bad idea to take your API keys and accidentally check them into GitHub. It happens all the time. You can go and crawl GitHub and pull people's API keys and email addresses and all sorts of other information out of there. So one of the things, if you use GitHub to save your code as a revision control system, you can check your notebooks that we're building into GitHub, and that's a very good idea. So you keep your changes and change. You can see what changes you've made, maybe revert back to old ones, but you need a way to not have those API credentials and stuff like that just baked into your code. Never bake credentials and stuff like that into your code. Bad idea. So this is a way that I've found to make it a little bit safer and easier to use credentials, but have them have it all work, but have them safe and not actually baked into the code itself. So this is let's see. So this is all based on custom secure notes. I know this is probably going into some really deep LastPass stuff, but LastPass allows you to create custom secure notes to put all of your credential material, like passwords and API keys and stuff like that. And so if you use Jupyter Notebook, and then I'll show you exactly how this works, you can keep all of your credentials in LastPass and then use the LastPass command line interpreters. So LastPass has an open source project called the LastPass CLI, and so all of the things that you can do in LastPass, you can also do at the command line. And so what I've done is I've written a little snippet of code, which I'll show you in a moment, which lets you actually access your LastPass keychain inside of the notebook, and then you never actually have, you do have those credentials in memory, of course, but you don't actually have them in the text of the code, so they never get saved to disk, and they never get sent out to your GitHub if you just accidentally check something in and you're like, oh man, now I have to rotate API keys and such like that. And so this is actually just how you set up your custom notes. But the first thing you have to do is to kind of determine the ID of that particular credential. So when you do, it's just like command line. You do an ls, to list the files. So this is LPass ls, and then it shows you all the different credentials that you have, and each one has an ID. This, I actually redacted this out there so you don't see my ID. I don't know. I'm just super paranoid. I don't know if these are like dynamically generated for my account, but I'm still not going to share it. But so you get that ID, and then what you want to do is, so this is my API key for my Threat Connect account. So so this would be the sort of thing. This ID is what you need to put in as an input in the snippet of code that I'm going to show you in a second. So this is it. So this allows anything. If you load this at the beginning of your script, you can load this anywhere. So this will actually, this uses Subprocess, which Subprocess is a way to take Python code and access command line tools. So what I'm doing here is I'm actually checking the status of LastPass to see, am I logged in? Like, have I authenticated into LastPass already or not? And if I haven't, it actually opens a terminal window so that I can go and log into LastPass, and then go back to whatever I was doing before, and then it'll get the credentials. So it takes the unique ID, and then you saw in that screen capture of LastPass, there are a bunch of different fields for the credentials. So whichever fields you have populated with data, you just give it a list of the fields that you want, and then LastPass kind of treats URLs. The URL that you want to go to is special, so you either tell it like you have a URL in there or you don't. And then this part handles grabbing the URL, so there's like a specific command line parameter for URL, And then this one just repeats until it grabs all the fields, and then it stores all of that in a variable and hands that back to the execution that you're using. Okay, so use stuff like this. I think I'll probably share this on GitHub somewhere, you know, when I get back later today. But this is another thing, and I'll show you this. So progress meters are really good because you know, when you're sitting there working on something that might be long-running code, and you've got a loop, you don't want to have the loop get stuck for some reason, you know, that you can't see, because if you're not using a debugger like PDB, you can't really see that something has you know, hit a wall or, you know, got stuck in a loop or something like that. So having a progress meter so that you can see that something is happening is really awesome. And this is an open source project, TQDM, which provides progress meters for command line Python and progress meters for in JavaScript in Python notebooks. So enough of that. Let's actually look at some Jupyter notebooks. So the first one I want to talk about is Cuckoo. So who is familiar with Cuckoo Sandbox? A few people. I know you're definitely familiar with Cuckoo Sandbox. But so Cuckoo Sandbox is a automated malware analysis system, an AMA. So Cuckoo allows you to take a suspicious or known malicious file and then do dynamic and static analysis on it. So you run the file in a VM, and then you observe the behavior of that file, and then you see the data that the file left behind in that particular VM. It also allows you to do a certain set of static analysis. So there's a variety of tools that are baked into Cuckoo that do static analysis. And static analysis is looking at the structure of a file without actually running it. And we're going to look at a few of the specific tools later on, but this is sort of an overview of Cuckoo. So let's take a look at Cuckoo. Let me make this a little bit bigger. Yes, is that good? All right. So what I'm doing here, and you know, this ID won't get you anything. This is nothing important. It's actually going to be rotated after I finish the talk. So, because I was trying to figure out, like, how can I not show the ID and still show the Jupyter notebook, and it's not possible. But so this is the ID in LastPass of the credential for my Cuckoo instance. And so you know, this basically imports that LastPass module that we just saw in the previous slide. The next thing, and also you know, I will do the live demo gods part of this, but I'm not actually going to do the submitting stuff out to the network and then wait for it. That's a little bit too risky for a live demo. So I've already run this part of the script. And so, by the way, just some Python. Who here is a Python programmer? Awesome. So who here uses pathlib yet? All right, start using pathlib because they fixed it. In Python 3.4 or 3.5, pathlib actually started working, and it's not a pile of garbage. And so, so what pathlib does is it unifies all of the different other tools and other packages and modules in Python, so that everything uses the same, like, path syntax. And so pathlib is awesome. I'm a great fan of it now. Was not a fan of it recently, but but it is awesome now. So you know, what this does is actually loads the sample.exe, and then this lets me send that sample over to my Cuckoo instance using Cuckoo's REST API. And also, by the way, I'm going to show you in the Jupyter notebooks that we're going to see today. I'm going to show you basically three general paradigms with Jupyter notebooks and how to interact with stuff. So here, I'm going to kind of show you, this is how you're going to interact with an API that's like out there in the world, REST API. So you want to use requests, and learn the syntax of requests. This is a great component to use to contact APIs. And then one of the other paradigms I'm going to talk about is using Subprocess, which we saw a little bit of, which lets you interact with command line tools in your environment. And then the third thing I'm going to talk about is actually interacting directly with files on the file system, and then loading them and stuff like that, and manipulating them. And also, all the stuff that we're going to see today is based on JSON and manipulating and investigating data that's in JSON format. Because all the APIs that we're going to work with, hopefully, most of the ones that I work with have JSON responses. XML still exists, but it's my grandfather's data format. What we'll see down here, so this is basically, I've submitted the file. It was successful. I got a 200 code back from the API, and then this is some metadata. This is metadata about the file that I sent. So it says, blah, 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 task ID, blah, 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 has been submitted to your Cuckoo instance. And so, this is the task ID that you want to ask that Cuckoo instance later on for the full report. So then I've got this. I just double checked. So this is I have drilled down to that specific report ID. So I save that into a variable called report ID, and then I go back to requests and I reach out to the Cuckoo instance and I ask it, please give me the report numbered 256703. And so then I get a 200 response code back, and then I take that response, and then this method called .json is a convenience function in requests, which just, if you know that your response from that API is JSON, you can just do .json method, and then the content here is actually takes all the JSON and then puts it into a nice Python dictionary. So that it just translates the JSON into a Python dictionary. So now here's the cool part. These are all the different components of a Cuckoo report. And so we've got a variety of different keys in this report. So this is the basic info. The info is the section about information about the report itself. So this is like what time the thing was submitted, and some information about kind of housekeeping information about the submission. Signatures, so these are the various signatures, Cuckoo signatures that might have matched during the analysis run. But since we're talking today about technical intelligence, we're going to focus first on network and network indicators and pulling network indicators from this report. And so I've gone ahead and done some of the work here. So this basically what I'm doing here is I'm just doing a pretty print of the JSON output of that dictionary. So this is the network report. So scroll, come on. So this is the network report, and I'm going to focus first, just in the interest of time. We can, I encourage you to go back and do this on your own and explore the complete report. But what we're going to do is focus today on the DNS part of the report, because the DNS requests that are going out from the malware can show you what the specific, if we go back to the that hostname layer of the pyramid of pain, this is domains and host names that have been registered or compromised by the adversary. So we're finding those, we're discovering those via the DNS resolution. So down here, what I've done, and actually I removed the part, I removed the cleaned up version just so that I can kind of redo that in front of you, so you can see kind of the technique for drilling down into this information. So what I've done is I've used TQDM to give me a nice little progress bar, and I'm just looking at each of the DNS entries, DNS objects in the network report. And so I'm just going to print each one of those objects, and like that. So what I want to do first is see what is, what I want to do is look at the first the request, right? So I want to print out each one of the requests and then put it with an answer. And so we would do print request and request. All right, so we've got all of those. These are the different things that were resolved. We have a number of false positives here, but at this stage you kind of want to you don't necessarily need to focus on false positives. You want to kind of collect the data from this and then use exclusion lists or something like that, because obviously Microsoft.com, this Torito IPv6, this is a false positive. This is the workstation checking its time and resetting the time. This is some suspicious stuff. So the .at and .it, and then OpenDNS. This is these OpenDNS and curl my IP, OpenDNS, and then this is a pointer record. So this is also each one of these is probably these are definitely false positives. What's happening here, these MyIP, is this is the malware reaching out to these IP checks to determine the IP address of the victim that it's just compromised. So these are probably going to be the information that we want to focus on, but let's take a look at what's happening here. So for what we want to do is say for each one of these, we want to look at the answers. So this is this section, so answers. Let's look at answers. Whoop, that didn't copy. For answer in request answers, print answer. Okay, so now we've got, we have a one-to-one relationship with each one of these, but let's try to remove some of the false positives and junk data. So we want to focus on the things that actually had a record response, an A record in the answer. I could care less about CNAMEs and pointers, and definitely don't care about NX domains. And so what we want to do is say, if answer type is a record. Now let's see what we get. So we've cleaned that up down to just A records, and then let's say we want to clean this up even more. So we'd say answer data. Whoop. Data. Okay. So now I've got this, and then we can go a little bit further and clean this up even more. But you can see now we've got a nice clean data set, and then you can start removing stuff that is false positives. So there's a ton of different things that you can learn from a Cuckoo report. So I want to take a look at another section which is fairly interesting. So if you go, so VirusTotal, who's familiar with VirusTotal? Awesome. All right. So VirusTotal is a system for you to submit a file, and then the VirusTotal behind the scenes runs that file through as many different AV and endpoint protection products as they can, and then gives you the results from all of each one of those AV products or endpoint protection, and then it gives you whatever the detection or the conviction results is from that product. And so let's take a look at what that report section looks like. So this is what it looks like. You've got, you've got you have a link that'll actually take you to the report itself, and I've already gone ahead and done that. So this is the report. This is what the VT's UI report looks like. Oh, excuse me. And so you can then look down here, and we've got all of these. We have the results here, but let's go and look at scans. So what we can do is look at the particular scans, and then we're not very interested in scans that have a null result. So let's say, so for scan in VirusTotal scans, print scan. All right, so we've got all of these scans. So there's a lot of different things that this was scanned with, but we want to focus on just the information that is important to us. So we want to get rid of all of that null data. And so what we would do is say, you know, if scan, let me look at the format of it. So if scan result is none, print scan. Let me just double check. It might, it wants result. Yeah, I see it. Oh, sorry. Hold on. Scan and scans. Ah. Go back. Oh, live demo. Okay, so scan, so that's the scan name. Scan and scan, so that's a scan name, and then I need another one for scan and then result, right? Sorry. Yeah, yes, you're right. Yeah, for a scan, for temp in scan. Yeah, no, that didn't work. I need to go another step down. Yeah. Oh, no. Sorry. Items. Scan and then results. Yeah, this is it. So results. There we go. Sorry. All right, so now we've got all these, so we can print the scan, comma, and then results. And result, right? And then we can actually say if this is not none, then show me that. All right. Okay, so there we go. So now we've got the scanner engine, the scanner engine name, and then you've got the scanner results. And so one of the things you can do with this information is, you know, look for, you know, write some regexes and look for some commonalities across the results, and then boil that down into a set of words, and then you can have what all the AV companies think this thing is. You know, you want to discount things like generic and throw out stuff like wisdom eyes and you know, Zeus and stuff like that. But you can, you know, boil this down into like an approximation of what the AV industry thinks this particular thing is detected as. So it's one way that you can actually get a head start on your analysis. Okay, so going back, the next thing I want to talk about is Bro. You are offline. What is happening? I don't know. I will not worry about it. Won't let you full screen if you're not connected, which is weird. All right, so Bro. What we're we're going to do is focus on one specific file and analyze it using Bro. And so what's interesting is, if you kind of, remove all the different tools except for one and then figure out what can I learn just using this one tool. And so what I've done here is sort of a thought experiment with what can I learn just from the PCAP of a sandbox run. And so, if you want to follow along at home, this is the SHA-1 of the file that we're going to look at here so that you can check my work and see it, or you can see it for yourself. So this is an Excel file called documents.xls, probably suspicious already. So this is these are the log files that Bro produces. This is not the full log file. Full log files are huge and have a lot of different columns, but I've shaved this down to just some of the information that I find interesting. And this is the command line way of working with Bro, but in a moment we're going to see the Jupyter Notebook way of working with Bro. So this is the connection log, and so again, just like in Cuckoo, we see a bunch of false positives and information that you want to get rid of. And so stuff like this where you have ICMP, which is going to a local address and all this stuff. You've got some, these are things that you might observe but are non-malicious and are part of the normal behavior of the computer. So you want to get rid of all that junk. And then, what you want to do is kind of observe what your sandbox results are if you put nothing in the sandbox or if you put something benign in there. And then you can see, see good and then find evil, so to speak. So this stuff obviously is not malicious traffic, but it is also interesting to analyze. So the DNS traffic, again, just like we looked at in the Cuckoo results, this is where you can find some of the network infrastructure. And then this is HTTP requests that are going outbound from the sample. By the way, let's go back to the fact that this is an Excel file, right? So an Excel file is making HTTP requests. That's extremely suspicious. And then after it finished making those HTTP requests, it's making some sort of request out on port 5651, and then Bro doesn't even know what protocol that is or what service that is. So that is extremely suspicious traffic right there. And this is what I'm going to show you. This is the command line way of doing it, and then we're going to look at how to do this via Jupyter. So this is in the DNS log. So those DNS requests that we saw just a moment ago, s1.yapfiles.ru. So you've got an Excel file that's calling out to a image sharing site, which we'll see why that's interesting in a moment. And then rmansys.ru, which is on one particular IP address. By the way, so this one, yapfiles.ru, and it has lots of different IP addresses. This could either be some form of, fast flux where they're, trying to rotate or doing round-robin DNS on, infrastructure controlled by the adversary. But no, this is actually a legitimate site, and these are, load-balanced IP addresses that are using round-robin DNS in a legitimate way. So this is YAP files. As we can see, this is a file upload. I know you don't read Russian, but this allows you to upload images. So this is like a kind of like Imager or something like that, where you upload images. And then that YAP, not YAP files, but the rmansys. So if you go to rmansys, this is one of those sort of gray area products that's like a keylogger. That they sell to spy on your kids or whatever like that, and it's called Remote Manipulator. So again, we've got like an Excel file that's calling out to Remote Manipulator infrastructure. So we have a pretty good idea of what might be the actual malware involved here. And so this is the this is the HTTP log, and so it's making requests. And by the way, if you look here, there's something very, I know this is kind of small, but it's reaching out to that file sharing site or the image sharing site for a JPEG, but Bro is telling me that that is MIME type X DOS exec. So it is probably not a JPEG file. And then I just verified, so I go and like visit that JPEG to see if it's actually a JPEG, and it is not, of course. You know, cannot be displayed because it contains errors. And then, so what I want to do is look. This is a FUID, so Bro puts UIDs on every row of data, so that when you can go from one log to another, and you can correlate which row in this particular log is related to a row in another log. So when you go and look at the file log, you can see that particular FUID, and you can see that that row in the file log is related to this row in the HTTP log. So this is the extracted file from that particular row in the file log. And then this is, again, I go back and this is the C2 traffic going back to the command and control IP address of the malware. So what have we learned from PCAP by itself? The adversary is probably Russophone. You've got Office documents generating network traffic. The payload here is remote manipulator. And then the payload is hidden on a public image sharing site as a JPEG. So this is like an attack pattern as we go back to what we talked about at the beginning. So let's look at Bro. So again, I've got, I'm using pathlib and all sorts of fun stuff like that, and loading all of the logs. So Bro, what it does is it dumps, when you run Bro at the command line, it dumps just a huge variety of logs based on each of the scripts in the Bro scripting language. And so you can write your own scripts that look at the network traffic and then produce, you know, a log of, you know, whatever you want it to be. But I'm just looking at the ones that are out of the box included with Bro, so things like HTTP, DNS, connections, and different protocols, mail protocol, and stuff like that. So what you see here, so I'm basically just loading each one of the files into a data dictionary. So we've got 10 log files, and let's see what is the. All right, so the first log we want to look at is the connection log. So the connection log is kind of the overall parent log, and basically, if you don't have a connection log, then the PCAP was empty. So the PCAP you've got for connection log has each one of the packets will have a specific connection here, and so this stuff, you know, what you want to do is look for a particular connection and then find the ID in the next. Yeah, so find this ID, and then you want to take this ID and look for this ID in another specific log. So, you know, this is ICMP. So this one is not going to have another log, but if you look down here, we've got DNS. So you'd want to look for this ID in the DNS log, and then that would correlate this particular connection with the more detailed information that you get from the DNS log. Okay. So that's Bro. I want to look at really quickly two static analysis tools. So Exif Tool, what Exif Tool does, it shows you metadata that's buried in the file itself. And so Exif Tool very nicely has a JSON output. So if you use Exif Tool and then the switch -JSON, you then get nicely formatted JSON output. And so what I'm doing here is I've loaded the sample.exe, and this is, so remember the paradigms that we were talking about. This is a paradigm of using Subprocess to access Exif Tool, which is a command line tool, and then still get nice, you know, machine readable output from that. and then manipulate it and analyze it using Jupyter Notebook. So you can see here Exif Tool with -JSON. I give it the file location, and then bam, we've got all of this we have all of this nice data that Exif Tool has taken out of the file. So one technique I want to show you here, which is kind of interesting, which Exif Tool is used for. So this timestamp, this is the compile timestamp from the PE information in the PE file. So PE is the format that Microsoft uses for executable files, or one of the formats. And so what I've done here, I'm not going to go into too much detail about what you're looking at here, but basically what I'm doing is I'm taking the timestamp and I'm normalizing it into Python's format called datetime, so that I can compare the datetime of the compile time to another datetime out there. So this is really cool. So what I've done here is grab this, and then I've got this is the normalized, Python syntax for datetime. Unfortunately, I wasn't able to get, from whatever IP address I was using, I wasn't able to get requests to reach out properly to this JSON feed of hybrid analysis. But hybrid analysis is a site where you can upload files and get dynamic analysis back. It's a free site. So one of the things that's really cool about this is I've got this analysis start time. And so the analysis start time is very interesting, because if I take the analysis start time and then I look at the compile time of the file that was submitted, if those two times are very close together, chances are the adversary is the one that submitted this file to hybrid analysis to see, is it detected? See if I can evade this particular flavor of sandbox. So the analysis what I've done here is taken, unfortunately I wasn't able to reach out to that data using requests, but I did dump it to a file called feed.json. And so what I'm doing here is I drill down to the analysis start time, and then I create a thing called submission timestamp, which is in that normalized Python syntax. And then what I do is, and this is just arbitrary, I picked 2 minutes off the top of my head. So 2 minutes, date time, so I create a time delta of 2 minutes. And then what I do down here is I take the submission timestamp and I subtract 2 minutes, and I see if that's less than the compile timestamp. And if so, I'll print adversary. And so compile timestamp, and so it obviously didn't print adversary. So what I did here, just to show you what would happen if these two were close together, I have gone ahead and manipulated the number of minutes here, and then changed put in a fake compile timestamp, and I've compared it. So submission timestamp minus 2 minutes, less than the compile timestamp, print adversary, and boom. So we've got an adversary testing their malware. The last thing I want to show you is strings. And so strings can be used for a lot of things. So strings basically is a command that looks for strings, like words, that are contained in the data in a executable file, or any file for that matter. And what I'm specifically going to show you here is hunting for PDB, so program databases. When you compile a program, you leave debug symbols in there for doing your debugging. So many malware authors are lazy, and they actually leave their debug symbol path in the malware. So it's good, if you've got a lot of malware files, to hunt for these PDB strings. So let's look for a specific PDB string here. So what I've done is I've grabbed all, I'm using Subprocess again. I'm grabbing strings. I've split lines, so each one of the strings is in a different element of an array. And so for string in strings, print string. And then, so there's, as you can see, these are all the typical, this program cannot be run in DOS mode, blah, 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 blah. But let's let's do this. So if we import regex and then say and then let's use the PD. So I have a canned PDB string regex. So this will find PDB strings that are of this format. And then let's say if, so match and then we'll see that in string, and we need to decode it, by the way, because it is, so let's run that. All right, that worked. And then if match, if match print string. And so let me decode that too. All right, so now we've got, we have a PDB string here. So users, admin, documents, Visual Studio 2012, projects, treasure hunter. So treasure hunter is actually a point of sale malware. And this is a very good indicator that what the file you have that you're working on, that it actually is of the malware family treasure hunter. And then if we had submitted this to Cuckoo, you could then look at those virus total results. And what I've done is I've just gone ahead and just shown you here. So the virus total results, if you go and look for repeating words across the different results here, you'll see, let's see, where's that? So treasure hunter, hunt POS, et cetera, et cetera, et cetera. So what the goal here is to go from just this collected data and then boiling it down into information so that you don't end up like Charlie on on It's Always Sunny in Philadelphia. So any questions? Thank you very much.